Okay. Am I doing? I guess I'm doing this part. So, all right. Welcome everyone to this webinar. I'll just start with some housekeeping. Just a reminder, I can't see the people in. Can you, Alice? Okay. I think when I have control, I don't have the bottom screens. Okay. So, sorry, I'll start again. Thank you all for joining. Just some quick housekeeping. Everyone is muted during the webinar, of course, but we would love to have your questions. So as we go through, please go ahead and enter them into the Q&A. You'll see those buttons at the bottom of your screen. You can enter them as we go, and then we'll have time for Q&A at the end. So I'm Kimberly Martin. I'm the co-chair of the EFFC and DFI Sustainability Guides Task Group, and I will be your MC for this webinar. I first want to wish everyone a happy Earth Day. We have many different backgrounds represented in this meeting, but our planet is a commonality among us all, so it feels special to be able to come together today to celebrate our planet and take time to make a positive impact through our work. Next, I would like to introduce our speakers. We have Luke Deamer, who will present on the Carbon Reduction Guide, which he led. Luke is the other co-chair for the Sustainability Guides. He's the head of the Sustainability Working Group for the EFFC and is Group Sustainability Manager at Keller. We're also joined by Alice Berry. She'll present on the Circular Economy Guide, for which she was the lead author. Alice is a sustainability champion through and through, a geotechnical engineer, and has recently taken on the role as the head of Net Zero for the Brighton and Hove City Council. So some of you may be thinking that these guides sound familiar, and that would be correct. A few years ago, these guides were issued by the EFFC, but under a new agreement with the DFI, these guides were updated and reissued, and going forward, the rest of the guides will be co-branded and address sustainability across the two groups. So we have a straightforward agenda today. I will provide you with some general updates, then Luke will take it away with the Carbon Reduction Guide, and then Alice will cover the Circular Economy Guide. We'll have plenty of time at the end for Q&A, like I mentioned, so please do enter questions for both speakers as we go. All right, I thought I would start today with thinking about where we stand against our goals when it comes to the EFFC DFI Sustainability Guides, the overarching UN Sustainability Development Goals, relevant legislation, so we're seeing a lot of that in the news, and finally, other drivers for taking a more sustainable approach. Starting with the sustainability guides, I'm happy to report that we're making great progress. Aside from the two guides we are discussing today, we're in the final stages with the water guide, which is led by Alice Little, and the climate adaptation and resilience guide, which is led by Marla Gillum. Next up, we have three guides, which will hopefully be written in parallel this year. We have the Wellbeing Guide that will be led by Catherine Chowder, the Nature Guide led by Rory Canavan, and the Gender Equality and Reduced Inequalities Guide led by Bradley Falkus. We have a lot of people interested in helping with the guides, but we could always use more help. We'd particularly like a co-lead for the Nature Guide to help Rory. So if you're interested, email Luke or me directly, or follow this QR code to fill out an interest form. The Environmental Pollution Guide will likely start in 2026, but we'll still take interested parties, so you can fill out the form for that guide as well. I want to share a quick status update on the UN SDGs from the UN perspective, since we're using these as our framework for the sustainability guides, and since today is UN Earth Day. The SDGs were written in 2015 with a goal to achieve them by 2030, which is actually not too far away. From the UN perspective, the SDGs are very focused and are applied at more of a country level. The UN Secretary General provides an annual update on the 139 targets that are within the framework. So for the 2024 report, most of the data came from 2023. So you'll see in this update, there's some green where we are on track, lots of yellow where some progress has been made, and then red where we've stagnated or regressed. We do need to keep in mind we had COVID in the middle of this time frame, and that was where a lot of setbacks occurred. But for me, from my perspective, this demonstrates how we cannot let up on our sustainability efforts. Most of what we talk about with our guides is how you and your companies can do better within your purview, so within your own projects, within your own workforce, within the communities where you operate. But as you can see here, there is a component of the SDGs that is beyond that scope. So I want to highlight that this is where corporate social responsibility at your respective corporations and institutions can really be impactful. It is where evaluating our supply chains, particularly those supply chains that go beyond our communities, can be impactful. And of course, applying the guidance we'll discuss today can go beyond our communities as well. So as an example, carbon reduction is a global goal with global impacts. So it's not all good news here, but I do think there's a path for us to contribute to the progress and make a difference. All right, next hot topic is legislation. Where do we stand on this? There are a lot of smaller regional reporting requirements coming into play, particularly in North America, but there are two key drivers on the legislative front for most of us here. For those of you from the EU or from companies that operate in the EU, I think the Corporate Sustainability Reporting Directive, or CSRD, is top of mind when it comes to sustainability in the news. It's a critical piece of regulation that will drive a lot of the institutional changes we want to see when it comes to sustainability. I'll spend a bit more time on recent changes with CSRD on the next slide. And for the rest of us in North America, the California climate legislation is going to be the big piece here. North America has some federal reporting requirements that are likely going to be held up in the courts for a long time or dropped, but the California climate legislation seems to be holding up and no reporting delays have been granted. So we expect this piece to hold. The California laws are less broad than CSRD, so if you're complying with CSRD, then you will meet the California requirements. However, due to the recent delay in CSRD reporting, for some companies, there can be a bit of a timing miss on some of the shared requirements. So we do just need to highlight how important it is to stay up to date on the regulations because it can be a bit of a shifting landscape. So if you work for a company that operates in the EU or you have clients that operate or are based in the EU, then you may have heard of the Omnibus proposal. This proposal simplifies and reduces the sustainability reporting requirements in the EU from CSRD and other climate regulations. Luke made this handy slide to illustrate the changes with the Omnibus package. What this means for most of us in North America is that we will see an increase over the next few years of required sustainability data points from clients and companies that are based and or operate in the EU. So as contractors and designers, we need to be prepared to provide that information. Although the Omnibus presents a lot of changes for the reporting in the EU is still leading the way when it comes to comprehensive sustainability reporting. And it seems most companies think of the Omnibus as a fair way to keep sustainability reporting and regulation alive, while also reducing the burden and keeping the focus on the points that will have the biggest impact. So where do we stand on the other drivers? We still see that sustainable business can help with winning work, whether because we are bidding on projects that are looking to get sustainability ratings like LEED, or through clients that are taking the initiative to do better, or through clients that are bound by the legislation we just discussed. We also see a continued interest by many of our current employees in the future workforce when it comes to working for a company and in an industry that is pushing forward to have a positive impact. Further, there's still financing for projects and companies that can be tied to sustainability performance. So we want to keep an eye out for projects like that. And lastly, doing business in a more sustainable way can simply be better business. Using a sustainable approach can lead to more efficient use of materials, creative ways to reduce the work scope, and innovation. So to say this plainly, all of the drivers listed here are related to economics, and that is, of course, a pillar of sustainability. I think keeping a tight focus on what we measure and recognizing where we can have some impressive impacts is a great path forward. And the best way to know what to do is through these sustainability guides. So with that, I'm going to hand it over to Luke to discuss the carbon reduction guide.
Thank you very much, Kimberly. And yes, this is the new look of the EFFC DFI carbon reduction guide. Now, before I move on, it's worth saying this is free to download from both the EFFC and DFI's websites. And there's far more content in this guide than I could possibly cover in this short webinar. So if you take one message away from this, it is please download and have a look through this free guide. Now, if I Move the slides on. Here we go. Brilliant. So this guide has 4 main sections. The first looks at what is carbon reduction, what is climate change, what does all of this mean to a geotechnical contractor or designer. We then look at why all of this matters to us. So as Kimberly so well educated us on just now, this includes things like existing legislation, but also the wider client demand drivers, bank pressure, efficiency savings, all of those great things. The longest section, though, in all of this is the how section. So here we look at quick wins for different companies. We look at future-looking statements for those that are already doing some great work. But actually, the majority of this section is broken up by function of a business. So regardless of whether you work on site, whether you're an engineer, whether you're designing projects, whether you work in procurement, IT, there is a section for you in this. The idea is to make carbon reduction relevant to you and your role. Then after going through those 3 sections, we finish with measure. So this looks at how we can record our emissions and also record our carbon reductions and our savings, both at a project level and at a company level. Now, one of the great additions we've had with bringing the DFI on board with these guides is these are not just contractor focused. So when we look at carbon emissions from a contractor perspective, we have our direct emissions on sites, and we also have the emissions of our supply chain. That's the kind of carbon footprint of our organizations. But when it comes to geotechnical design, we can think of it more as a handprint, because the direct emissions from a designer themselves, the office, maybe commuting to and from a site, are relatively small. But what they're able to draw with their designs is by far the largest carbon impact that they have. So whilst contractors have the direct carbon footprint, we can think of this designer carbon handprint going forwards. To try and quantify that a little bit, you may recognize this diagram from the original carbon reduction guide, but we can divide up contractors' emissions into 3 main scopes. These are set out by something called the Greenhouse Gas Protocol. So if we start on the left here, we start with scope 1. These are direct emissions from our fuel use. So particularly our use of rigs, pumps, generators, things like this on our sites. We then have scope 2, which are all indirect emissions from our use of electricity. And whilst these are mostly from maintenance yards and our offices, occasionally this is also for site equipment. And then we have scope 3. Now, as you can see there, scope 3 is by far the largest scope. It's typically around 80% of our emissions on a heavy foundations project, because scope 3 covers all other indirect emissions. And in there, whilst you have some from business travel, waste disposal, material transport, effectively any fuel used by non-contractor vehicles that sit outside your company, by far the largest source of emissions are our use of cement and steel, because they're both energy and carbon intensive to produce. When we look at this from a designer's perspective, though, it's worth saying that always that scope 3 piece, those all other indirect emissions from our supply chain, are somebody else's scope 1 and 2. So that's how you can start to quantify it and add it all together. However, what's interesting when we look at the designer perspective is that they have a perspective not just on the foundations of a project, but on the overall design as well. So what they need to consider is not just what we term capital carbon, which is the emissions of contractors and their supply chain, so making the foundations themselves, constructing an asset, but they can also think about the operational carbon, so that's running, building, infrastructure, something like that, and also the user carbon, so how that asset, that piece of infrastructure, is used throughout its lifetime. Now, why does that matter for us and for this specific guide? Well, it's interesting because it means that we can sometimes invest more capital carbon, so contractors can produce more emissions, building a heavier foundation project if it reduces the overall life cycle emissions of an asset. So some examples of that to bring it to life a little bit. Installing a ground source heat pump with some heavy foundations is higher carbon than just installing the foundations alone from a capital carbon perspective, i.e. it uses more resources, uses more energy to install it. However, throughout the operations of that building above it, it will save carbon, and it saves far more carbon than was invested initially because it reduces the building's need for heating and cooling. Similarly, from a user carbon perspective, we might think about a road. That's the classic example in all of this. So if we wanted to just reduce our capital carbon, so the emissions of the geotechnical project itself, we might make sure the road goes round the terrible geology, so we can just do ground improvements. So we do not even need heavy foundations. But that would mean vehicles taking a longer detour. And if you have thousands of vehicles every day taking a longer route, it will use more fuel, it will produce more emissions than investing in heavier foundations and making a straight road instead. So this is where that designer perspective becomes quite interesting compared to the contractor piece, where we can actually manage our direct emissions and our supply chain. So how do we go about actually creating change? How do we go about actually reducing our emissions? Well, for this, we can first turn to a carbon hierarchy, like this one from our guide. Basically, this just means that we do the big things first. So often we skip straight to innovative materials and substitution, but this ensures that we get the efficiency savings first. So at the top of the carbon hierarchy, we look to eliminate emissions completely. This means looking at things like reuse of foundations on urban sites, testing them to enable their future reuse. It also means eliminating the use of carbon-intensive materials like cement and steel entirely, so switching to methods like ground improvement where we can, where the settlement is permissible. From an actual company operations thing, though, it's also where we can optimize things like travel. So doing as we are now with webinars rather than visiting directly online, of course, reduces our emissions. From there, we can look to reduce our emissions. And this is where often good ground investigation can mean that we can optimize designs, reduce pile depth, pile diameter, things like this. And it's also where we can bring out the efficiency of our processes. For example, anti-idling methods within our vehicles. Or it's where we can look at other efficiency savings, because anything that saves fuel saves carbon, but also saves cost. It's the same with materials. Only once we've worked through these two stages can we look to substitute our emissions. This is where we can look at more innovative low carbon cements. Anything where you can replace ordinary Portland cement with something like ground granular blast furnace slag or pulverized fly ash will reduce its carbon intensity. Similarly, if we're using recycled steel or recycled aggregate instead of primary steel and aggregate, then again, it is a lower carbon solution. It's also where we can look at alternative power for our equipment, whether that is biofuels from waste stocks, or indeed things like electricity to our site. Finally, once you've worked through all of that carbon hierarchy, it's then about quantifying the carbon emissions from a project or from a company so that you can look at carbon negative solutions, ground source heat pumps that we've mentioned before, or even offsetting those emissions through an accredited scheme. So let's get into a bit more specifics on all of this. And here we have the different sections of the how-to guide. So you'll see, as I said before, we have quick wins for somebody just starting out on their decarbonisation journey. At the end, we have innovation and future-looking statements for those that are more familiar with decarbonisation. But between those two sections, it's all focused on different parts of a business. So again, you can turn to the section that is most relevant to you. I've highlighted 2 in yellow here because these are the most changed from the first EFFC carbon reduction guide. These are the ones that have seen the most updates in the last couple of years. So firstly, again, thank you to all of our DFI colleagues that helped write and input into this guide, because we were able to split out design into what is possible right now and what might be available in the future. And interestingly, some of the future-looking statements I mentioned before, when we published them in 2022, we thought were going to come in the next decade, and some of them have very much already arrived. That also means that we've seen new technologies come out, likes of alkali activated cementitious material, AACMs, and other low carbon cements and materials starting to come through into geotechnical designs and builds for the first time. So here are some examples of the kind of content within this guide. Now I've summarized them to put on a slide here. There is more detail in the guides themselves, but broadly, this is about signposting you to other resources where you can get all the detail that you need for your specific project or your specific company initiative. You'll see there, these are the quick wins. So the first one is all about reducing cement use. So here we talk about using ground improvement, again, where you've got low load or acceptable settlements that you can bring in. Also specifying low OPC, ordinary Portland cement mixes. Certainly over here in Europe, we use often up to 70–80% replacement for typical CFA board pile type projects. You need to consider things like project operations and curing times, but there are many opportunities there to learn from the wider EFFC DFI community. Also in here, we have reuse of materials and reduce waste. I will not talk too much about that because I know Alice Berry will talk to that with the Circular Economy Guide shortly. But again, anything where we can reuse things like sheet piles, steel screw piles that are traditionally reused anyway, ultimately save us carbon because we can keep using them again and again. There's a couple of things on efficiency here, both around efficient use of existing kit and optimizing design, but also as rigs and equipment come up to the end of their natural life, thinking about what equipment we buy at that stage from an efficiency perspective, as well as a capability perspective. It's also worth noting that, as Kimberly pointed out earlier, different states and indeed different cities within those states have air quality legislation requirements under what's called the NRMM, the Non-Road Mobile Machinery Directive from the EPA. So therefore, making sure that we buy kit, given our rig might have a lifespan of 10–15 years, that we can still use in that time, and is also going to be efficient, save us fuel over that time, makes a difference overall, rather than risking a stranded asset in the future. We have to highlight connecting to the electricity grid. Of course, the actual carbon saving varies depending upon the sources of electricity for your specific state or your specific area. But generally, connecting to the electricity grid saves carbon and also improves air quality for that site. So it's better for your workers and the local community. Finally, though, education and awareness has to be pulled out as a quick win, because whilst we had many great authors on this guide, we will never be experts in everything that people do. So if we can bring our site teams up to speed, but also our designers, our procurement teams, everyone up to speed on carbon reduction and what they can do, then they can start to embed it in their own processes. Start to drive carbon reduction from the bottom up in a company as well. In the updated guide, though, I think this is perhaps the most exciting update of all of this. We've also added case study boxes for the first time. Now here, I've linked these case studies to a diagram from something called PAS 2080, which is a carbon management in building and infrastructure standard. And broadly, it says the earlier you get involved in a project, the greater the carbon saving you can achieve. So if you have the opportunity to completely challenge the proposed design from a client, you can do far more, or change the geotechnical solution, you can do far more than just once you're on site trying to switch out for different fuels or materials. So just to pull out a couple of those case studies, you'll see there's a foundation reuse one, talking about all of the testing they had to go through in order to reuse some board piles as they went through a pier extension. It also talks ultimately, even after the costs of that increased testing, how much money and therefore tons of CO2 they were able to save by reducing materials used and time of their project. There's a materials substitution case study, which looks at replacing that ordinary Portland cement, what we term CEng 1 here in Europe, with a CEM 3B, which is effectively 70% slag and 30% ordinary Portland cement, resulting in, again, about 51% carbon saving on a project. From a more site operations perspective, once we get down as a contractor onto site, there's an interesting case study where for a 4-month-long project, they started off with 4 diesel generators on site, 4 diesel gensets, but actually from a commercial perspective, made the switch to grid electricity power, saving over $100,000 and 290 tons of CO2. It's worth pointing out that that includes extending the wiring earlier onto the project so that they could get the electricity onto site. Finally, and I think this is quite an interesting one because it doesn't necessarily save carbon itself, but indirectly has a big impact. One company contributed a case study talking about how they use the EFFC DFI carbon calculator to estimate their emissions after the design stage of their project. They then use that as a carbon budget for the duration of their time on site. So much like they were seeing, were they on track to meet their financial budget, they also had a carbon budget that they were trying to beat at the same time. This also helped improve their future design carbon calculations. That segues nicely into the final section of the EFFC DFI carbon reduction guide. And as I mentioned right at the beginning, this looks at both calculating your carbon emissions at a project level, but also at a whole company level. Now, hopefully you've seen on the left-hand side, you've seen this part before, because the EFFC DFI carbon calculator is a free to download Excel tool that helps you calculate the carbon footprint of a geotechnical solution or an individual technique within that solution. Critically, it also allows you to compare between different geotechnical solutions, say what is lower carbon for an individual project. Now, we've been promoting this. You may have seen the 10-year anniversary post about the carbon calculator last year. So it's now close to 12 years old. And you may also know that Luca Bruni and Chris Nelson from the EFFC and DFI are leading a task group to try and update this carbon calculator right now. Nonetheless, it's a really powerful tool because it provides a common language for all of us to calculate carbon emissions using the same emission factors and the same system boundaries. So what's included and excluded from the carbon calculator. That way, all of the companies represented in the EFFC and DFI can compete on carbon rather than on calculation methodology. What's new in this guide, though, bringing on board the DFI as well, is that we now have a company carbon reporting tool. This is a simple input form. It's a simple Microsoft form that we originally devised to help benchmark the emissions from our sector. So we don't know the carbon footprint of the overall geotechnical contractor and designer markets, but through this, we're starting to estimate them. What this tool became, though, and why it's so useful to all of those on the call, is that this allows for company level carbon calculation. So if you know your scope 1, scope 2, and scope 3 emissions, those emissions from diesel, electricity, and materials, great, you can put those in. And we will help benchmark anonymously your company against the others in the sector. However, if you don't know your carbon footprint, this will help calculate it for you. So it's free to use again for any DFI member as well. But if you put in your use of diesel, your use of gas, your use of oil, your use of electricity, and where you are based, it will calculate your carbon footprint. So this is a great quick tool to try and estimate that carbon footprint for your organization and help comply with some of those client and legislative demands that Kimberly outlined right at the beginning. So with that, thank you very much for listening. I'm going to hand over to Alice Berry to talk about the EFFC DFI Circular Economy Guide.
Thank you very much, Luke. So I'm going to talk you through some of the updates for the Circular Economy Guide. It follows a similar structure to the one that Luke introduced for the Carbon Reduction Guide. So going through what is the circular economy, why it's in our interests to aim for a more circular economy, how we can do it, and a little bit on how we could measure it. So what is the circular economy? Well, to answer that, it's important to understand how our economy works at the moment. For most things that we consume, there is a process where we extract raw materials. So in the case of a piled foundation, that would be the iron ore and aggregates for concrete and so on. That gets manufactured into components. So maybe your steel bars and then your reinforcement cage and your concrete installed. Foundation goes in on site, it's used during its normal life, and then at the end of life, if it's a part which is above the ground, often it ends up in landfill. Our component parts of our piling rigs, for example, would ultimately end up there. Or maybe if it's a deep foundation, it just stays in the ground and forms a bit of a blight for future developments where there are obstructions in the ground. So the aim is to move towards a more circular economy whereby materials and components are circulated at their highest value, and rather than from extraction through to being disposed of, they're refurbished, they're repaired, they're reused and recycled as much as possible before any disposal happens. So a little just thinking test for you. The question is, how much do you think sand and gravel alone accounted for in all raw material use by weight in the European Union in 2019? And then we've got a little poll question for you as well, which is, how much do you think the construction and demolition sector waste was by weight again in the EU in 2021? And the answer is quite large. So approximately a quarter of raw material use in the EU was construction, sand and gravel, and approximately a quarter, 25 to 30% of all waste generated, again, was attributed to the construction and demolition sector. So there are, making changes to work towards a more circular economy, as us working in the ground engineering area, can make quite a significant impact. There are some other drivers as well. So on the bottom left here, there are the efficiency savings. If we can use less materials and less virgin materials, we should have significant cost efficiencies and also reduced risk. We've all seen the impacts of inflation in material costs over the last few years, and material scarcity and difficulties with energy security. So reducing our material use should help with that. There's the financial and legislative pressures and the client demand and employee demand that Kimberly was also talking through at the very start of the webinar. And all of those add up to be making quite a strong case for trying to reuse much more than we currently do in ground engineering, and also to enable future reuse as well. So the circular economy got kind of three main aims, which are as follows: to eliminate waste and pollution, to circulate products and materials at their highest value, and to regenerate nature. But this particular guide concentrates specifically on item number 2, circulating products and materials at their highest value. Regenerating nature, we hope will get covered in the forthcoming nature guide, which is hopefully going to be start writing this year. And eliminating waste and pollution, there's quite significantly covered by legislation in some countries, although not so thoroughly in others. And in terms of contaminated land and contaminated groundwater, there is quite good existing guidance. And so we've got the hyperlink to existing guidance at the end of the document, but this particular guide doesn't aim to cover that again. In terms of getting towards a more circular economy, there is also a hierarchy of actions here. And so the aim should be to prioritize the actions that have the greatest impact. And that tends to be actions that involve using less resource. So options where you can get a similar solution without having to build anything. So this might be, for example, on a congested set of train tracks or congested road, implementing a smarter signaling system to avoid having to build additional lanes or additional tracks. It also covers found and reuse, which is common across areas, but is still definitely not that mainstream. And also doing what we hope we've always been doing, which is to have efficient designs. Then circulating at highest value. So trying to reuse foundation elements where we can and enable in our designs and our specifications for that to happen. Maintaining and refurbishing our plant and equipment to extend its useful life, and also enabling future reuse of foundations by having very good records, so that that's not a lack of information is not a barrier to their reuse. After that, the aim is to eliminate waste and pollution, so responsible selling on of our plant and equipment, and also avoiding use of polluting and hazardous materials as much as we are able. And then disposing responsibly where we still have to dispose, aiming for recycling, use of materials as secondary materials, energy recovery, and safe disposal. So this guide has got a section on how we can aim towards circular economy, and is again split up by function. So if you are in procurement, you can look specifically in the procurement section. If you are running a yard or an office, there's a section for you. There's also a much increased section on influencing the client and design, as the Deep Foundations Institute covers design, whereas the European Federation of Foundation Contractors, which wrote the original guide, was more focused specifically on construction. And of course, at the start, some key quick wins, so areas where if you haven't taken much action yet, you should be able to implement these fairly easily and get some good results. This joint guide has specifically got updates in these areas, so a bit more on desk studies. So when considering reuse of foundations or other geotechnical elements, a prompt to also consider not just the original design and construction quality and the use of the foundations since then, but environmental impacts that could have occurred during their use. So earthquakes, floods, and changes in groundwater levels. There's more about insurance, because often getting agreement for insurance can be one of the tricky elements of getting foundations reused. And so this can be facilitated by having those consistent, meticulous records of as-built foundations, understanding appropriate risk sharing between clients, contractors and designers, and the insurers, really, so that those best able to control the risk are allocated that risk. And also a reminder about various codes and best practice guidance that exists. So complying with that guidance tends to improve the insurability of a foundation reuse project. And again, there are links at the end of the document to further guidance. And an update on legislation. So on the waste legislation and fees in various countries, and then specifically on the Canadian directive and the US Game Changers initiative funding, and the other legislation that Kimberly was talking about earlier. So these are relevant as well. And as we know, it is a constantly changing picture, but these drivers are probably going to get more and more important. So I did want to go over again some of the quick wins, because it's always worth checking how we're doing here. So one of the quick wins is to optimize our designs. As designers, we like to do a good design anyway, but it's worth remembering again that having a design that uses less material and is more efficient can contribute to a circular economy. Also, enabling specifications to allow proposals of alternatives, of alternative materials, of reuse components, and allowing time in the process to do this. So that's now the bottom right-hand box over here, that early designer and contractor involvement can be the influential thing that enables a particular reuse to occur in a project. It takes more time and effort generally to work through those quality checks if you are reusing something, although you tend to save money by doing it. But if there's not time in the program, that can often be the barrier, which is a shame. Reuse of temporary works, so steel sheet piles, screw piles, cross bracing and so on, that can be used again, and then having a system, if you're a contractor, for getting those temporary works from one site to another, and a sort of, a marketplace, as it were, for that. Asking suppliers if they have pre-used materials that could be used. Also segregating waste at source, which should enable much better recycling of our materials. And again, procuring products that are easily separated into these component materials, and keeping meticulous records of our as-built foundation geometry, the quality insurance, the concrete cube records. All of this is really helpful for supporting future foundation reuse. If we've got time for a poll now, it'd be good to see if we can launch the poll. If you click on the 3 buttons down on the right-hand side, I was going to ask how we're doing in terms of implementing those quick wins in our organisations. But it's possible we might not get that working. So I'll move on for the moment. So in another set of the section of the guide, we've got information on how to reuse materials and component parts right now. And one of the areas where it's good to focus our efforts is reuse of the soil and rock that we excavate. So topsoil can be sold on and reused. Granular fill, so granular material, subject to the right testing and quality control checks and so on, can be used as an engineered fill. And where we have clay fill, that can either be treated to use as fill, or maybe potentially nowadays also as a construction material. I'll talk shortly about the use of calcined clay as a cement replacement in concrete as well. And influencing the client and the design. This is again important, particularly for both reducing material usage, but also enabling repair and reuse. And I know I keep saying it, but I'm going to say it again, that thorough record keeping and the meticulous data, and keeping that data after the warranty period is finished, can be really helpful to enable future reuse. It also gives us design, if we're detailing our designs with potential reuse in mind, that can help, and allowing for future flexibility, but at an appropriate level. It's probably counterproductive to enable any future foundation loads to be carried, but if there's a foreseeable future change, then we should design that in already. So looking to the future, some of this is now actually happening already. So extendable hollow piles is some piles like this have been installed on projects nowadays. So a hollow pile that you can then send an auger down through in the future to make the pile longer. Also, technology is advancing quite fast now on calcined clay and using that as a cement replacement in concrete. And also the use of crushed concrete as recycled aggregate, although obviously there are technical considerations, particularly for tremie concrete. And then looking to the future, we maybe one day have reversible ground improvement or foundations as a service, where you can sort of rent a certain load bearing capacity of the ground, and a particular contractor or company would provide that and keep it maintained and suitable for flexible future use. Removable foundations, full life cycle assessments on our projects, and increasing use of off-site prefabrication, which can also enable better reuse in the future. So Finally, measurement. You may have your own project level metrics that you want to derive, you know, percentage of reuse or particular aims for a certain project, but there are also these internationally recognized sustainability accreditations such as LEED and BREEAM, which have circular economy elements in them. And at a company level on the right, there's various accreditations that also have elements that cover the circular economy and how that's implemented. So that's it from me, and I believe we're now open for questions. I'll hand back to you, Kimberly.
Yes, thank you so much, Alice and Luke. I have a few questions for you to get started. As a reminder to everyone on the call, you can go into the Q&A at the bottom and enter in your questions for our speakers. So, Luke, I know we get this a lot, and you talked a little bit about it with the graph, but we hear this all the time. Isn't Scope 3 double counting emissions?
Absolutely, and it's worth saying from the start, by definition, that's exactly what Scope 3 is. It's also why it's a challenge to tackle that big bubble, the biggest source of our emissions. But yes, our Scope 3 is somebody else's Scope 1 and 2, and we've tried to visualize that in various different ways within the guide. However, just because it's produced by our supply chain rather than by us doesn't mean we don't have an impact. So we can still influence that Scope 3 piece. Some of that comes from engaging with our supply chain and picking out strategic supplies, but also from a design perspective, we control how much and what types of materials we go for. So that's why we have to include it in our carbon footprinting. It's also worth saying that our Scope 1 and 2, so our fuel use and our electricity use, as well as our supply chain emissions, become our clients' Scope 3. So that's why our clients are asking for this information, is because it is their Scope 3 emissions, which they then add to that use phase to get their own Scope 1, 2, and 3 emissions.
Yeah, thanks. And I think of Scope 3 as kind of proving we're all in it together. And I love how in California with the cement industry, they're pushing through legislation to require the decarbonization of the cement industry by 2045. You know, that really put it in everyone's purview, right? Like, you all want concrete and cement, so let's all do this together and figure this out. And it's not any one person's responsibility, it's all of our responsibility. So I do like that about the double counting, if you will. Alice, I had a question for you about the meticulous record keeping. You've been talking about for people designing things now that will be reused in the future. You have experience reusing foundations in the past at Arup. So my question to you is, what are the kind of key things you want to make sure people record for foundations now so that we can enable easier reuse in the future?
Yeah, well, I mean, I would say that all information is really valid, and it's important to understand the original design loads and design intent, the foundation geometry, the size, the location, as built rather than just design. And then beyond that, it's all of the construction records that we take at the time for our quality control. So understanding, you know, the materials testing, the concrete cube records, particularly things like that, where it may be that the concrete is actually stronger than was specified, and that's really useful information for future reuse. You know, the as-built records of the reinforcement, and also any, you know, non-conformances and how they were dealt with. And it's also really valuable information. And I would say that keeping that can be quite a financial advantage to a company in the future. We have cases now where both contractors and designers have been paid a fee for providing that information that enables foundation reuse, because it saves the client money overall. But it is a case of needing deep understanding and kind of, you know, you cannot go in and look at the foundations in the same way you would look at a beam or a column. And so the more information you have, the easier it is then to check a little bit of it rather than starting completely from scratch.
And we have kind of a follow-up question. And when you're going to reuse right now, what do you think the main barriers are? Is it the lack of information? Is it the risk? What do you see happening now?
I think it's a combination of factors. I think sometimes it's the difficulty in obtaining the insurance, which is a risk perception, and the fact that you can't completely check every foundation. And so again, that's why it's important to have that information there, because that provides a lot more certainty and a lot more comfort. It is also, I think there's often a program issue that it takes more time to go through the checks that you need than just to design a set of new foundations. And it saves the client money overall, but doing the investigation necessary to check that the foundations are suitable for reuse can cost much more money up front, because it's more complex than a standard ground investigation. And until you've completed that, there's still an element of risk that you might find that the foundations are not suitable. So it's partly a client confidence and a mindset thing. But I think as we have sites that get more and more congested with successive generations of foundations, it becomes more and more attractive to reuse what's already there, because finding a gap between them gets pretty hard.
Yeah, and it just feels so wasteful to not be able to use what's already there, right? It doesn't feel
Indeed,
good.
yes.
Luke, I have a question for you. You mentioned biodiesel. We talk about renewable diesel. It's required in California. I also hear it in the news, particularly in the UK. It seems like that it's not all great. So what are your thoughts on renewable diesel, where it's a good transition fuel, and what we can do about it?
It's a really good point, and I'd always point back to that carbon hierarchy as a starting point, right? So I'd always rather that we try to reduce the amount of fuel we use initially before we start looking at things like biofuels and alternative fuels. So anything that you can do to, I mentioned anti-idling before, but again, right-sizing equipment for a project, switching to an electricity supply, even if it's just for your welfare cabin, for example, is a great starting point before we start to look at procuring things like renewable diesel and biofuels. To the point on biofuels, though, I think they are a very good stepping stone for decarbonizing our existing equipment before we eventually move to electric, hydrogen, whatever hybrid type of technologies you want to do in the future. That's because they are a plug-in and play with our existing kit. And we have so many case studies from around Europe of people using biofuels quite happily in existing rigs. We've got sign off from the majority of the rig manufacturers. So it's just a sort of plug in and play, and beyond some sorts of overconsumption, typically between 5, 10, 12%. Other than that, they work fine. The thing that you do need to check, and I think what you're pointing out here, is that they are from waste stocks. So the actual carbon saving of biofuels themselves comes because the plants drew down carbon when they grew, and then there's a bit of processing, which is the emissions, but then you're just releasing the carbon that they drew down when you eventually burn that fuel. Now, that in itself is fine. And if it's been used, for example, as waste cooking oil, or it's the waste from remainders of crops, then that's still a real carbon saving. If, however, it's from a deforested area of the rainforest, as sometimes you get with palm oils, then clearly that has a negative biodiversity impact and potentially negative carbon footprint as well. So that's why we talk about different certifications for biofuels, so that you can ensure it is from a waste stock. The likes of Zenmo Fuels, for example, there will be equivalents in the US as well, just to make sure that carbon saving is genuine and that there isn't a risk of crossing over into biodiversity impacts.
Awesome. Thank you for that. Alice, I have a thought for you. So there's the old famous saying, necessity is the mother of innovation, and I'm feeling like tariffs could be the mother of the circular economy. So we heard in our in some of our sustainable construction leaders meetings that I've had that we're actually seeing GCs interested and owners interested in reusing materials, because not just they may be more expensive from the tariffs, they can be harder to get. And so we're seeing this growth of, okay, let's segregate waste, and maybe this old door could be reused. You now have this perspective of working, you know, on the government side and for the city council. And I'm thinking, do you think this drive for reuse should come from the government, should come from private industry, a partnership? Just kind of how do you see encouraging more reuse of materials? Oh, you're on mute.
Yeah, I think it needs to come a bit all round. It can help if there are legislative and policy drivers for sure. But when it's making good economic sense, then it should snowball and keep going on its own. At the moment, some of the barriers are they're technical in terms of the amount of extra due diligence that needs to be done. And so that can be quite off-putting because there's not enough time or there's not enough experience in how this is done. And if there's just a cheap and easy way to use a virgin material or you build something new, then that's kind of the way it's going to go. So I think, yes, if it becomes harder to just use virgin materials, that should spur on that extra effort required to get familiar with reuse. So yeah, I think that's definitely could be an interesting situation to watch play out.
It could be. I agree. It's just, I feel like people weren't forced to do it, to try and figure out the infrastructure and the logistics to bring the economy into that more circular system.
I think the other thing that can be tricky at the moment as well is that the thing that could be reused and the place that you want to reuse it may not be geographically or temporally that close. And the question is, where does it get stored in between, and how do you kind of protect understanding of the provenance of your reused sheet pile or whatever is being reused, so that you've still got that quality control. So maybe the Internet of Things is coming to geotechnics as well.
Yeah. I'm like, could AI help us with that, please?
There are some genuine good networks that we've highlighted with some case studies from different parts of Europe, particularly Germany, where they have systems to help share, where people go, I've got this amount of work, left over from my site. Does anybody want it? And they try and connect up these projects. So it's amazing what is possible. I was going to ask you though, Kimberly, as our North American resident, what the kind of availability looks like for some of these low carbon technologies, low carbon materials that we've spoken about in the guides and very briefly in this webinar, how you can go about trying to source these in such a broad geography as North America.
Yes, it is very broad, and we find that these low carbon materials are regional. For example, fly ash will be available in the southeast of the United States, and slag is available in the northeast and the eastern part of Canada, if you will. Slag gets imported to the West Coast, so we can get it there, also into Florida. So yeah, it is regional. People just have to keep an eye out, really stay in communication with their supply chains to see what's becoming available where. We're constantly surprised and just keeping an eye out from the industry in general and saying, oh, it looks like someone's using renewable diesel in the Northeast. We didn't think that was available there. What supplier are they using and how can we get that? So yeah, it's just kind of, I think, taking that deeper look into the supply chain and paying attention to what you're buying, and hopefully finding that some of these recycled, reused materials are more cost effective as well. All right. I think we're just about at time. So thank you again, Alice and Luke. We learned so much from you as usual, and we appreciate you going the distance, staying, working late into the evening over in the UK to round out our Earth Day with some good news and some really great advice and tips for our industry and people in our industry. So go download the guides and go download the carbon calculator as well. And hopefully we'll be talking soon. Thank you again.
Thank you.
Thank you.